Hello classes. Today let's start further pure mathematics. First, we have confirmed that you have learned pure 1, 2, and 3 before and build a well basic. Okay, let's turn to the first chapter, complex numbers. Before we learn this chapter, initially, your priority will be to check these 5 questions here. First, simplify each of the following. That means it's a question about the third with a huge number. You should know how to simplify these thirds. And for question 2, in each case, determine the number of distinct real roots of its quadratic equation. So you should have learned how to fix it and factorization or use complete score. Or you can recite the roots formula and the discriminant to justify the situations of the roots. And question 3 for the triangle showing. And for this question, this is the right triangle here. So you should know the Pythagorean theory, trigonometric function, the property for the trigonometric function, sine theta and cosine theta, and what is tangent theta, and the relationship between them. For question 4, find the solutions of a quadratic equation. And it's like the question 2, a lot of knowledge in the quadratic questions. And for question 5, it is denominator here, it is very complicated. So we should try to use rationalize and to simplify this denominator and make it into a rational number. So I can confirm that you can fix these 5 questions out, and we come to our first chapter, imaginary and complex number. And we have got our number system. The greatest number system here is real number. Then we use Venn graph to express this system, real number. And inside it, there is rational number. And here it is sub. But there is the questions here. For the equation, quadratic equations, if the discriminant is less than 0, there are no real roots here. That means in our current number systems here, no real number can express the number like the square root of negative number. So we should extend our number system. We call a number like this, we call it imaginary number. We use letter I to represent the square root of negative 1, then outside both of them, we call it complex number. We written it in the form of a plus bi, and we also use letter C, the capital C, to represent a complex number. So here, first, I equals to the square root of negative 1. Then we return the form as bi, we call it imaginary number. We written complex number as form a plus bi. And here, if b equals to 0 and it only need left a here, it's a real number. And we color this part with green. And if a equals to 0 and b didn't equal to 0, we call it imaginary number. We color this part with yellow. And the left, we color this part with blue. So if a didn't equal to 0, b didn't equal to 0, that is a plus bi. This corresponds to the blue part. So far, the greatest number system is complex number here. We use REZ to represent A as the real part of complex number. And we use IM blanket Z to represent B, it is the imaginary part. So for imaginary part, it's only B, not BI. Our biggest number system, greatest number so far, it is complex number. And next, calculation principle for the complex number. In today's lessons, we learn the addition, the subtraction. Then, real number multiplication. Addition and subtraction. A plus bi add or minus c plus di. We adding the real part with the real part, and the imaginary part with the imaginary. So that's the minus. So subtraction. A plus or minus c plus b plus or minus d. So this is the addition and subtraction principle. Just real parts correspond to real parts. Imaginary part with imaginary part. So second, real number multiplication. We use real number by lambda multiply a plus bi. And we just use distribution as we use in algebraic operation. So it is lambda a plus lambda bi. Multiply out the brackets as we do usual. It's just okay. And this is two principles. One is addition and subtraction, and the second is real number multiplication. So let's do some practice. For example, 1, the square root of negative 36. So we separate into negative 1 times 36. We left this one out is 6, and then negative 1. Square root that it is, we use I to represent this one. So it is 6i, it's the last results. And for the square root of negative 28, that is do the same thing as before, and times 28. Left this one out. This is 2 times the root of 7 and then times I. So we use a bracket here. Or we can write it in 2i the root of 7. we avoid the form like this because this one is easily to confuse with this one. So we just choose this expression, or choose this expression like this, or choose the expression like this. And for the operation, we can use add, or we use these questions. 18 plus 5i they are all subtraction and constantly, continuously, and just subtracting the real part with the real part, and subtracting the imaginary part with imaginary part. That is 18 minus 15 minus 3 plus 5 minus negative 2 minus 7i, and this one is equal to 0. And for this one, it is equal to 0. So it says 0 is a real number. For the questions 4, it's a questions about the real number multiplication. So we choose this one. For the first, the sub is in the denominator. Make a rationalization to the denominator. Both denominator and the numerator multiply, form of conjugate. It is the root of 3 minus 1. And we extract the 2 out. 1 minus 3i. The denominator is 2. So eliminate both 2 from denominator and numerator. And then we do the real number multiplication. Distribute this expression into brackets. That is, multiply by 1 and 3i respectively. So it's final answer. For the next chapter, we will learn the multiply between the complex number and complex number. But today, a plus bi and a minus bi. We find this form for these two complex numbers is more like a plus b and a minus b. The relationship between them is conjugation. So the calculation, they are similar to each other. So if we do addition, that is 2a, and if we do the subtraction, this is 2bi. And if we learn the multiplication from them, we will know more about the conjugation operation in a complex calculation. Oh, so much for this. See you next time.